Our story begins with a man named Andre Smith. He's an unknown physicist known for his theory on creating your reality. The mental, physical, visual, and emotional, which align with universal laws, creates. One of his most notable theories, the theory of reality, revolutionized our understanding of the mental, physical, visual, emotional, time, and probability. But Andre's genius didn't stop there. He also made significant contributions to another field of study, one that is both perplexing and fascinating: quantum physics. Quantum physics, in its essence, is the study of the tiniest particles that make up our universe. It's a realm where the rules of classical physics crumble and give way to phenomena that seem to defy logic and intuition. The world of quantum physics is one where particles can exist in multiple states at once, where they can be in two places simultaneously, and where their behavior changes just by being observed. Consider, for instance, the famous double-slit experiment. In this experiment, particles are fired one at a time through two slits onto a screen. Now, you'd think that each particle would pass through one slit or the other and create two distinct lines on the screen, but that's not what happens. Instead, the particles create an interference pattern, a series of light and dark bands, as if they have passed through both slits at the same time and interfered with themselves. Even more baffling is the fact that this interference pattern only appears when the particles aren't being observed. The moment we try to peek at which slit the particle goes through, the interference pattern vanishes, and we get the two distinct lines we initially expected. This experiment raises a myriad of questions. How can a single particle go through both slits at the same time? Why does the act of observation change the outcome? And perhaps most importantly, what does this tell us about the nature of reality? Could it be that reality is not set in stone, but rather a malleable construct that bends to our observations? Could the act of observing not just reveal reality, but also shape it? And if that's the case, what does it mean for us, the observers? When I contemplate the fascinating world of quantum physics, I cannot help but feel amazed by its impact on our reality. It is intriguing to think that we, as individuals, are integral parts of the creation and are composed of particles. Furthermore, our perception of the world is unique to each of us, and we can shape our reality through mental, physical, visual, emotional, time, and probability. They remind us that the universe is not just stranger than we imagine, but stranger than we can imagine. And as we delve deeper into the quantum realm, we can only wonder what other surprises await us. So next time you find yourself gazing at the stars or marveling at the complexity of a single atom, remember that you're not just an observer in this universe. You're a participant in its creation. And who knows? Maybe the act of pondering these questions will, in and of itself, shape the answers.